Hey guys, happy Wednesday. I felt like on Tuesday afternoon we left before we really wrapped up well, and so rather than wait until Monday, I thought I would give a couple minutes and go over that last question that we didn't get a chance to go over. And you remember it looked like this if you have two possible floor plans and we're comparing the two things, that sort of thing. So what I want you to do is I have it open in a discussion on the page right here. And what I'm going to do is walk you through it like we do with all these problems. If you get to the point where it's like, aha, I know what to do from here, then stop the video, work it out on your own, and then when you're done, go back to the video and see if you're right. And then put your work down in the discussion below. And let me know at what point your brain went, ah, there it is. Now I know what it is. All right? So I'm going to start off from the very beginning here. Let's read the question and pull our data out and see what it's asking us to do. So two possible floor plans for a new bathroom are shown. All right. So this is a plan in scale, right? Now we don't know much about the scale. We don't know if it's feet or meters or yards or whatever it is, but we don't need to know. It's asking, is there a value of x so we're finding what x is basically, for which the perimeters are equal. So in other words, the perimeter of this floor plan here is going to be the same as the perimeter of this floor plan here. So we're looking for the value of x that'll make both of these perimeters equal. And show your work and explain your reasoning and all that stuff. So if we're looking for equal perimeters, well, what that's saying is the perimeter of this first square has to be equal to the perimeter of the second square, right? We could say like P1 is equal to P2, right? The perimeter of the first is equal to the perimeter of the second. So we have to set that up. What does that look like if the perimeter of the first is equal to the perimeter of the second? Need to turn it off yet? Need to go a little bit further? We'll go a little bit further. It's okay. Well, first of all, we have to find out what the perimeter of the first one is and find out what the perimeter of the second one is and then put those equal to each other. Now, we know that this perimeter 1 is a square, and we know that because of these 4 tick marks on each of the sides, right? 1 tick mark each means all 4 sides are the same. Over here in the perimeter of the second one, we got 2 tick marks on 2 sides and tick marks on the other sides, and the tick marks are different, which means this one's a rectangle, right? That this side and this side are the same, and that side and that side are the same. Now, this side's labeled, that side's labeled, and on the square, one side is labeled. So that tells us what the length of one side is on the square, and what the lengths of 2 sides are on the second square. You have it yet? Ready to pause? Oh, a little bit more? Okay, we'll go a little bit further. If we're looking for the perimeter of the first side, we know that that's all 4 sides added together. And we know that this first side is x plus 3. So I know that if we do x plus 3 4 times, that gives us the perimeter of the first one. Nope, a little bit more? Okay. Well, if we have 4 times this length, then that means the perimeter of this first square would be 4 times x plus 3. And that would have to be equal to the perimeter of the second. So what's the perimeter of this second square? Well, it'd have to be x plus 4 plus x plus 1 plus x plus 4 plus x plus 1, right? Because you're adding all 4 of these sides together. So let's put those together and see what we have. So we have 2 times x plus 1 plus 2 times x plus 4. Aha, there we go. Now we have an equation set up, right? And all we have to do for this now is to simplify this equation to find out what x would be. And if we find out what x is, that tells us what we can put in to find the side for P1 and the 2 sides for P2, which will make this perimeter equal that perimeter. So there we go. There's your equation. You know how to solve it by now. So give it a shot, show me what you get, and come back afterwards. We'll see how you did. Okay, welcome back. Let's take a look at it. Now, as I'm sure you've noticed, it's an awful lot of distribution for this one, right? We got to distribute the first one, distribute the second one, distribute the third one, and then after we do that, there's a whole bunch of terms that are added together, so we can start combining terms then. So 4x plus 3, well, 4 times x is 4x, plus 4 times 3 is 12. 4x plus 12. 2 times x is 2x. 2 times positive 1 is positive 1. Plus 2 times x again is 2x. And 2 times positive 4 is positive 8. Okay, so that's the next step down. Now we got to start combining these terms. So we have a 2x over here and a 2x over there. And we have a positive 1 and a positive 8. So we can combine that 2x and that 2x. That gives us 4x. And positive 1 plus positive 8 is positive 9. So we got 4x plus 9 over on that side. Now over here, on this side, we don't have anything we can do, so we just take down 4x plus 12. Okay, oh, look what we have here. We have a 4x on both sides, and then a 12 and a 9. Well, 4x plus 12 equals 4x plus 9 is what it's telling us. But 4x plus 12 can't equal 4x plus 9, can it? Well, we can keep on simplifying and find out. An easy way to do that is we can get rid of that 4x on one side, right, by subtracting out 4x. Do the same thing to the other side. Aha! Both of those 4x's cancel out. What we're left with is 12 equals 9. Now, there's nothing we can do about that, right? Even if we wanted to try to combine these terms, we could take 9 away from both sides, right? Nothing wrong with that mathematically. Those 9's cancel out to 0. 12 minus 9 is 3. But 3 doesn't equal 0, right? So remember what happens if you get nothing for your answer but two constants that don't equal each other. Then it's not an equality, which means there's no answer to it. There's no solution. There's nothing you can do. So with our first plan and our second plan here, there's nothing you can put in for x that would make these two perimeters equal each other. Now, you could make two squares that the perimeters do equal each other, but in this case, we just can't do it with the dimensions that were given. So that's as far as that was. Pretty easy, wasn't it? Once you get it set up, it kind of solves itself, and then once you get to a certain point, you say, oh, wait a minute, no, it's not simplifying. Then that kind of gives you its own answer. So, what else do we have for today? We have a puzzler. I love puzzlers. Little riddles for you. You've probably seen these before in 6th and 7th grade. Teachers love this stuff. It comes in a big book, and you can pull it out. So what I've chosen for y'all is an exercise in inequalities and graphing the answers, which is, it's not difficult. They're just one-step inequalities, but it's good practice. So give that a shot, and have a great holiday, guys. And take it easy, relax. Don't think about school too much. And I'll see you back here on Monday. All right? Have a good one, guys. Bye.